Good morning, everyone. Myself, Nihalika, and today we are seeing the topic propositional logic. Inside that, we'll see atomic and compound statements. So, atomic statements, a statement which cannot be divided further. That means it cannot be divided into subparts, which is also known as simple statement or a primary statement. Like any simple statement, like milk is white, we cannot divide this sentence into smaller parts. So this is a type of or an example of atomic or a simple statement. Compound statements. Uh, Next is the compound statements. It is made by combining two or more atomic statements. So if two or more atomic statements are there, using the connectives, if we combine them, then it forms a compound statement. So two or more simple statements can be combined to form a new statement. These new statements are called compound statements or molecular statements. Example, it is raining today and there are 20 tables in this room. So, and is the connective here in this sentence, and two atomic statements or the simple statements are it is raining today, there are 20 tables in this room. And using the connective and this sentence, two atomic statements are combined together to form one compound statement. So, compound statements can be formed from atomic statements through the use of connectives. Example of connectives are not, and, or, if then, and if and only if. What are these? We'll look into further slides. So next are the connectives. The basic connective is the negation. So if P is a statement, then the negation of P is also written as negation P and read as not P in a statement. That means if any simple atomic statement is there, we can say, example, if P represents a London is a city, negation P means London is not a city. Suppose if Q means I am happy or Q represents I am happy, negation Q means I am not happy. The truth table for the negation is given as follows. So two values for P we can say is it can be either true or false, and when the responding negative negation P, we can see that if P is false, the negation P will be true, and if P is true, negation P will be false. So only two values for P can be there, either it can be true or false. If it is true, negation P will be false, and if value of P is false, negation P will be true. Next connective we'll see is conjunction, which is also known as and. So it is represented as this symbol P and Q. So this is read as P conjunction Q or P and Q. If P and Q are true propositions, then the conjunction of P and Q is the statement P and Q, which is read as P and Q. The statement P and Q has the truth value T whenever both P and Q have truth value T, otherwise it has the truth value false. What to understand in this, we'll see. So since two variables are there, P and Q, okay, so the formula for how many combinations we'll make is 2 to the power n. So first we'll write two trues and then two false and then two twos. So total 2 to the power 2 will be 4. So total 4 combinations will be there. Okay, for P and Q respectively, total 4 combinations. So we are able to see total 4 combinations. So when P is false and Q is also false, so P and Q will be also false. So for this to be true, P and Q to be true, both P and Q have to be true. So if P is false, Q is true, then also it will be false. If P is true, Q is false, then also P and Q will be false. But only when P and Q both are true, in the last case, last combination that we have, then the output will be P and Q output will be true. Only in this case, when both the inputs or both P and Q are true, then only P and Q will be true. This is also known as conjunction. P conjunction Q also we can read this as. Next is disjunction. So disjunction is also known as OR. So this is represented as P or Q. This is read as P disjunction Q or P or Q. If P and Q are two propositions, then the disjunction of P and Q is the statement P or Q, which is read as P or Q. The statement P or Q has the truth value F only when both P and Q have truth value F, otherwise it has the truth value T. What does this mean? So since two propositions are there, two variables are there, P and Q, so we'll have two variables, 2 to the power n. So n is 2 here. So 2 to the power 2 will be 4. So total 4 combinations will have. So 2 falses, 2 trues, 1 false, 1 true, 1 false, 1 true. So this will make sure that we have all the possible combinations. So in case of OR, when either P or Q is true, the output will be true. Okay. So when P is false, Q is false, P or Q will be false. When P is false, Q is true. Since one of them is true, we'll get the output as for P or Q as true. And when P is true, Q is false, we'll get it as true. And when both P and Q are true, we'll obviously get it as true. So we are able to differentiate that in case of disjunction, only in one value we are getting as false when both are false. Okay, otherwise even if one of the inputs is true, we are getting as true. Well, in case of conjunction, we are able to see that only in case if both P and Q are true, only then we are able to get true. Otherwise, in every condition, we are getting it as false. Okay. So this is for today. We'll look into the next topics afterwards. Thank you.